This is a video on solving rational equations. First, let's go over the steps to solve rational equations. The first thing you want to do is, rational equations contain fractions. So the first thing you want to do is determine the least common denominator, the lowest common denominator for all fractions that appear in the equation. And to do this, sometimes you might have to factor the denominator first. So if there's a polynomial in the denominator, you want to factor it and then use those as the factors when you're trying to find the LCD. Step 2, you want to multiply the LCD. You want to multiply the least common denominator that you found in step 1 to every term on both sides of the equation, right? Regardless if it's a fraction or not. So everything gets multiplied by the LCD, every single term. This will clear fractions out. Right? So that's why we do it, because we want to clear fractions and it'll make it easier to solve our equations. Step 3 is to distribute, to remove parentheses. Alright, because you want to be able to solve this, so to solve it first you have to remove parentheses. Next you would solve as normal for equations. Meaning for a linear equation, meaning things that just have x to the first power, you want to get x's on one side and your constants to the other. Or if it was a quadratic equation that you result with, you want everything on the left side and 0 on the other, and then you can solve by factoring. And then step 5 says to check to make sure your answer doesn't create an undefined term. Alright, meaning a 0 denominator in the original equation. So once you get your answer, you just got to look back and see, does it make my denominator equal 0 or not? If your denominator equals 0, you have to reject the answer. If it doesn't, then you're good and you can keep that answer. Alright, let's take a look at a couple examples. So for the first one here, we got 4x over x squared minus 9 is equal to 5 over x plus 3 minus 2 over x minus 3. And to solve this, remember the first thing we said we needed was to find an LCD, but before I can do that, I want to factor every denominator completely. So if I have x squared minus 9 here, this is the difference of squares. So I want to factor this down 2 sets of parentheses. Remember, x goes in the first part of each of them. Negative 9 means we need a positive 3 times a negative 3, right? Because 3 times 3 is what gives us 9. That makes 9 a perfect square. One's got to be positive, one's got to be negative. So that's how that factors. The x plus 3 over here can't be factored, and the x minus 3 in the last term can't be factored either. Once we have that, remember, we want to find the LCD. So the LCD here, alright, is going to be x plus 3 times x minus 3. Basically, the way you find the LCD is you want to look at all the denominators you have here, and you're looking for the highest power of that factor that appears. So I have an x plus 3 factor here that's to the first power, and I also have an x plus 3 factor here that's the first power. So I only need x plus 3 to the first power. If either of them had been to another power, you would take the highest power you see. And then you also need the other factors that appear. And x minus 3 is a factor that appears in one of the denominators. It also appears in this denominator, so we want x minus 3 as well. So as long as a factor appears in one denominator, it's part of your LCD. Once you find the LCD, you want to multiply it to each term. So I'm going to multiply 4x over x squared minus 9, alright, times the LCD, so times x plus 3 times x minus 3 is equal to 5 over x plus 3 times x plus 3 times x minus 3, so multiplying by the LCD to the second term, minus here 2 over x minus 3 times x plus 3 times x minus 3. Now realize I'm multiplying every term by the LCD. This x squared minus 9 down here, really I can rewrite it as I did up top, as x plus 3 in the denominator times x minus 3. Alright, so it's all in the denominator there. And when you multiply each term by the LCD, the reason we're doing this is to clear fractions, remember. And the way it works is anything that's common to the numerator and the denominator can cancel out. So I'm allowed to cancel x plus 3 here with the x plus 3 here, x minus 3 here with the x minus 3 here. So the left side here is going to be 4x. It's going to be equal to, on the right side, the 5 over x plus 3 times x plus 3 times x minus 3. The x plus 3's will cancel out. Right? Those are common to both the numerator and denominator. So I'll be left with 5 times x minus 3. Minus here, I'm going to have, we got 2 times x plus 3 times x minus 3 all over x minus 3. The x minus 3's will cancel out. So it'll be minus 2 times x plus 3. Alright, and notice fractions are gone. That was our goal, to clear fractions. That's why we multiplied by the LCD. If for whatever reason you didn't clear fractions here, it means you did not pick a good LCD and you'd have to start over. Once I'm here, I'll solve as normal for equations. So I'm going to distribute through. So I'll have 4x is equal to, this is 5 times x will give us 5x, 5 times a negative 3 makes us minus 15. And here, remember, you're distributing a negative 2. Watch your signs. So negative 2 times x will be negative 2x. A negative 2 times a positive 3 will make this a negative 6. And we can combine like terms. So if 4x is equal to a 5x minus 2x will give us 3x. Minus 15 minus 6 gives us a negative 21. And then, if I want to solve this here, I've got 4x equals 3x minus 21. I want to subtract 3x from each side. Subtract 3x here, and I got x equals, these cancel out, a negative 21. And that'll be the answer. When you do this, make sure you always go back and check. Does it make any of my denominators in the original equation undefined? Or make it 0, really. Make the denominator 0 would create a fraction that was undefined. Well, looking up here, in the x squared minus 9, if I substitute negative 21 in for x plus 3, that won't be 0. If I substitute in for the x minus 3, negative 21 minus 3 will be negative 24, so that won't be 0, so it's okay there. Same thing here, right? 5 over x plus 3, if I substitute negative 21 in for x, negative 21 plus 3 is negative 18, that's okay. And for 2 over x minus 3, same idea. If I substitute negative 21 in there, negative 21 minus 3 is negative 24, so that's okay. So negative 21 is a good answer, so we keep it. Alright, let's take a look at another example. Alright, so we want to solve 3x minus 2 over x plus 1 is equal to 4 minus x plus 2 over x minus 2. And when we're looking at this, our first step here, again, is to find an LCD. Now realize that we don't have to factor either of these denominators because x plus 1 and x minus 2 don't factor. So in the last example we factored because we had something that could factor, and here we don't have anything that factors, so we don't worry about it. So we're ready to find our LCD, right, our least common denominator. And remember, you want every factor that appears in a denominator to show up in your least common denominator. So in the first fraction I have here, the 3x minus 2 over x plus 1, the denominator is x plus 1. That's a factor that shows up in a denominator. We need x plus 1. 4 doesn't have a denominator. It really has a denominator of 1, but we don't have to worry about it because anything times 1 is just itself. And then x plus 2 over x minus 2 has a denominator of x minus 2, right? That's a factor that we have down there. So our LCD is really going to be x plus 1 times x minus 2. Now remember, we do this because we're going to multiply it to every term. So this is going to be 3x minus 2 over x plus 1 times our LCD, which is going to be x plus 1 times x minus 2. Now realize when I say I'm multiplying this, 3x minus 2 times that, I should put the 3x minus 2 in parentheses like this because eventually when we multiply, you have to multiply the entire term. Alright, so you don't want to just multiply one piece or the other. You want to actually multiply the whole thing. Is equal to 4 times the LCD. Well, the LCD is x plus 1 times x minus 2 minus, watch your signs here, it's a negative sign, so you're going to put a minus here, and then we're going to have x plus 2 over x minus 2. I'm going to put that in parentheses, just like I did earlier with the 3x minus 2 over here, because I'm multiplying that times x plus 1 times x minus 2, the LCD. Alright, now I'm ready to cancel things. So for this first fraction, 3x minus 2 times x plus 1 times x minus 2 all over x plus 1, the x plus 1's cancel out, and I'm left with 3x minus 2 times x minus 2. Make sure you got parentheses around both, because that's going to tell us that we're going to FOIL in the next step. Is equal to, here I got 4 times x plus 1 times x minus 2. If there isn't a fraction here, alright, you still multiply by the LCD like we did, alright? That's very important. Multiply a constant by the LCD. But then what you want to really do is just FOIL these together and then distribute the 4 through. So it's going to be 4 times, and I'll FOIL this, x times x will give us x squared. We'll get a negative 2x from my outer and a positive 1x from my inner, so it'll be a negative x. And then from my last, I'll get a positive 1 times a negative 2, which makes that a negative 2. Alright, so all we did here was FOIL to get the inside of this. Minus. We've got x plus 2 times x plus 1 times x minus 2 all over x minus 2. The x minus 2's will cancel out, and you'll be left with x plus 2 times x plus 1. Notice fractions are cleared. If I had not cleared fractions here, then I wouldn't have picked a good LCD. Right, and also notice that there were no fractions in the term with the 4, so we just multiply it as normal. It's just multiplication. Now we got to simplify this. And to simplify this, we have to distribute to remove parentheses. So in cases where you have a binomial times a binomial, we're foiling. Alright, so you're going to have 3x times x gives you 3x squared. 3x times a negative 2 is a negative 6x minus 2 times x is another negative 2x, so negative 6x minus 2x is a negative 8x. And then a negative 2 times negative 2 makes that a positive 4. Is equal to, let's distribute through here, 4 times x squared is 4x squared. 4 times a negative x makes that minus 4x. And 4 times a negative 2 makes this negative 8. Here we got a minus sign, we got to keep the minus sign. And then I want to FOIL x plus 2 times x plus 1. When I do this, I want this whole thing in parentheses because this negative sign in front belongs to the whole thing. So I need to put this in parentheses and then distribute the negative through. So we're going to have x times x gives us x squared. X times a positive 1 makes it positive 1x. And then for my inner I got positive 2 times x was positive 2x. So 1x plus 2x gives us a plus 3x. And then 2 times 1 makes us a positive 2 here. And now I'll distribute the negative sign through this set of parentheses. So I'm left with 3x squared minus 8x plus 4 equals 4x squared minus 4x minus 8. Now remember, this is really like a negative 1 in front. You want to distribute the whole thing through. Negative 1 times x squared makes that a negative x squared. Negative 1 times a positive 3x makes that a negative 3x. And negative 1 times a positive 2 makes that negative 2. Alright, now we combine like terms. We got 3x squared minus 8x plus 4 on the left side here. On the right side, 4x squared minus x squared gives us a 3x squared. A negative 4x minus 3x makes this negative 7x. And then we got negative 8 minus 2, which makes that negative 10. Alright, now I'm ready to solve like normal. We get my x squared together on one side, so I'm going to subtract 3x squared here. To move to the left-hand side, subtract 3x squared here. And what ends up happening is 3x squared minus 3x squared ends up canceling out. And on this side they also cancel out. So I'm left with negative 8x plus 4 equals negative 7x minus 10. So we have negative 8x plus 4 is equal to negative 7x minus 10. And to solve this, I'm going to add 7x to each side here. So I'll add 7x, add 7x. I'll be left with negative 1x, or negative x, plus 4 equals negative 10. I'm going to subtract 4. Subtract 4. These will cancel out. We get negative x equals a negative 14. So to solve for x, we're going to divide by a negative 1, divide by a negative 1. And we get x equals 14. Right, and we can check this to make sure our denominator doesn't go to 0. Remember, our original denominators we had x plus 1. Well, 14 plus 1 would be 15, so that's okay. And 14 minus 2 here would be 12, so we're good there too. As long as the denominator doesn't come out to 0 when we check our answer, we're okay. So, here are a couple for you to try on your own.